Hello everyone, welcome to Baozi Training Leetcode solution. If you want the best marketing video experience in North America, feel free to check us out at baozitraining.org. Today we're going to talk about the problem Leetcode solution 257 binary tree paths. So the problem is giving you a binary tree, so they want you to print out all the passes, note all the passes from the root to leaf. For example, if it's like this, 1, 2, 3, 5, and 1, 3. I don't think the order, if you look at basically the method signature, the order doesn't really matter. So any kind of order should be fine. So the thought process sounds like an easy problem. So what we can do, like I said earlier, whenever we're dealing with trees, think about traversal. Oops, sorry, I'm at the airport, so sorry about that. We need to think about traversals. There could be in-order, pre-order, post-order traversal, or level-order traversal. For this problem, a pre-order traversal should be good enough. So essentially, you start from the top, and then you keep traversing through the depth of the trees, and then you keep all the passes, and then as long as it reaches to the endpoint, essentially the recursion terminating point is a node, is a leaf node, then you return. So that said, one caveat is just need to handle, well, you don't need to handle it particularly, but just remember, right? So there might be a case it's just a node with itself, so it's just A, so you don't need to have this like arrow pointed out. So the way to handle this, you will see here. So this is kind of like the main method, and then we have a helper. So as long as the root is a null, we just return. Or if the root left is null and the right equals to null, in this case, we know this is a node that we want to return, so we added it to the final result. Else, we just keep appending the string because we know this node definitely has a left or right children. That means it definitely has a children, right? So you're gonna have this arrow sign regardless. So you just append the value and then append this arrow sign, and then this is more like the pre-order. So you do something and then you go to the left and then you go to the right. So for this tree is you do something, you append 1, and then you start appending 2. You check if it's a left or left. If it's not left, is there a right? Oh, there's a right. If it's as long as it doesn't have any children, so you append the result 1, 2, 5, and then similar thing for 1, 3. So the time complexity is O(n) because you visit each node once, and the space complexity is O(n) because you just need a string length of n just to capture, well, not length of exactly n, but to the order of n to capture the entire thing because you have these extra things. There's a Leetcode official solution where give me 1 sec. Here.
Good afternoon, ladies and gentlemen. Japan Airlines Flight 1 to Haneda will be ready for boarding at 3:35 p.m. at gate A7. If you need any assistance, please feel free to contact us. Thank you.
So another way is basically using the iterative solution. So how do you use iterative solution? We quickly talk about this problem in this one, binary search tree iterator, right? So you need to keep track of your stack state. So how do you do that? Just by using an extra stack. So the way, if you want to implement it iteratively, is here's the code snippet in case you don't have the premium subscription of Leetcode. So it keeps like 2 stacks. Well, you can define your own struct, but sure, you can keep 2 stacks. It's basically like this. 1 stack is the string, the other stack is the tree node. So as long as the tree is not empty, you push 1, the tree node, and also you push the string in there, right? And then you use extra stack. This is pretty much the extra stack. So as long as this stack is not empty, you keep popping. As long as you pop this out, you check if it has a left child or a right child. If so, append to the string 1, 2, and also put this node into the stack. So now you have 2 and 3 like this. And then you check, oh, is this a stack empty? No, now you pop 2 out. So, okay, in this case, let's say you pop 3 out first. And then you check, okay, 3 left and the right children is all empty, so you push 3 to the final result. Or you push 2 out. Now you push 2 out, you see, okay, does 2 have left or right children? It actually has a 5, so basically you push 5 out. Now you have stack is 5 and 1, 2, 5. And now you basically pop 5 out. You see, okay, 5 is a leaf node, so 1, 2, 5 is actually good. You append it to the final result. It's just like this. The implementation is here. So they just use 2 stacks. So the time complexity is O(n) still, because each node is basically exactly once, and the space complexity is O(n) because now you're actually utilizing extra stack, and then you could say it's O(n) log n for the stack, and the string size is still grows in terms of O(n). Okay, that's all I want to say about this problem. Let me know if you have any questions. Feel free to leave any comments. I'll see you guys next time. Bye.